In this section, we're going to look at transformations of functions and how do we do those different transformations. And so, what is a transformation of a function? So, in the previous video, we took a look at parent functions. Remember, parent functions are like your quadratic, like your x squared, or your square root of x, or your reciprocal functions. Those are ones that we should have memorized as to, what their basic properties are. And so what a transformation does is it basically either shifts a parent function up, down, left, right, um, or it expands it or contracts it. And so we could also reflect the parent function in one of the axes, and then we could also do some stretching or shrinking of the parent function. So essentially, we're just going to take our parent functions and move them around based on key points on those parent functions. And a lot of times it's going to be centered about the origin or maybe some other key points. So the easiest ones and the most common ones, believe it or not, are going to be the vertical and horizontal shifts. So how do we move a function up, down, left, right? And so if there's a number on the outside of parentheses, a constant, and we either add or subtract, that's going to move the parent function up or down c units. Okay. So if I had x squared plus 1, okay, or even in the diagram below, x squared minus 3, f of x is x squared. And remember, this is the parent function, the one that's hyphenated. And the transformed function just moves down 3 units. So we move down 1, 2, 3 from this central point right here. And this would be the same point. In fact, all points are going to be moved down 3 units. And so whatever this point is right here, this is moved down 3 units. This point over here is moved down 3 units, and they're all in the graph. So that's all that a transformation does, a vertical transformation. If the number is on the outside of the function, it just moves it up and down. Now, if the number is on the inside of the function, plus c and minus c, and be careful with this, we would think plus c is going to move it to the right, but in fact, a plus c inside of the function is going to move it to the left. Okay, so be careful with that. So if we had f of x plus 3, it would move it 3 units to the left. Okay, and then similarly, if we have f of x minus a constant c, that means it's going to move it c units to the right. Okay, so just be careful with what's inside the function. And so down here, an example, if we have our good old square root function, and remember, a square root function has a domain of 0 to infinity, and so we have this origin point. What we would do is we would just take that origin point and move it 1, 2, 3 points to the right. And in fact, every point has been moved 3 points to the right. Okay, so that's what a transformation is. Okay, for x minus 3. Okay, so now, there's also reflections, okay, in the x and y axis, okay? So if you take the opposite of a function, that's going to reflect it in the x-axis, which just means you're going to flip it upside down. That's probably the easiest way. So if the negative is on the outside, you flip it upside down. And then if you have the negative x on the inside of the function, right, then we're going to reflect it in the y-axis. So what that means is you're just going to swing the points around. So all the points, so for instance, if we had, let me draw this a little bit better. If we had this point 1 or 2 comma 1, which would be on the function as best as I can, then the point, so this would be, just imagine that this is the point 2 comma 1, then this would be the point negative 2 comma 1. All right. So basically what that means is all these points, these x values become negative and they just get flipped around inside the y-axis. All right. So we're just kind of flipping it around, if you would, over this side. Right. Now, there's other kinds of transformations as well, other than the reflections in the axes. Right. So there's these shrinking as well as compressions, okay, or stretching. All right. And we have these rigid transformations. Those are the ones that we've studied. Okay, so rigid are vertical and horizontal. All right. But and then also the axes. Okay, so reflections. So in other words, rigid transformations, they don't change the shape of the graph, just the position. Okay, so they just move it up, down, left, right, reflected, etc. okay? Non-rigid transformations are going to be stretching and shrinking the graph. And so if for some reason you just go through and say that you're going to multiply the entire everything inside the function by a constant, if that constant is greater than 1, then you're going to have a shrinking of the graph, right? But if the number is between 0 and 1, that means you're going to stretch the graph out, okay? So if I had my parent function, my quadratic, and let's say for some reason we did this, then that might be something like, since this number would be between 0 and 1, that might be 0.5x squared, okay? So in other words, it would just stretch that function out, okay? We'll see some examples of this, okay? So that's what we mean by stretching, and then by stretching and shrinking. And then vertical stretch means it's just going to go up faster or go up slower. And so that's what these vertical stretches are on the outside of the function, okay? A lot of times what we could do is we could just plot a few points to help us to determine what's going on with this, okay? So again, vertical stretch is going to be if the value c is on the outside of the function, okay? So maybe I had like 2x squared, okay? And that would be like a vertical stretching of that. And a vertical shrink would be if the number is between 0 and 1. All right. Now, if the number is less than that, okay, remember, if the number is negative, that means you're going to have a reflection in an axis potentially. All right. So just keep that in mind, that that's why we're only keeping positive values. All right. So let's do some examples of this really quickly, and then we'll do some more in some subsequent videos. So in each of these, we're just going to name the parent function. We're going to identify some transformations, and then we're going to sketch the graph of the function. So we start off with a pretty easy one, f of x equals x squared plus 2, okay? So we know that that's going to be a quadratic function. And we know that the function is going to look something like this, okay? As best as I can draw it, okay? It's not going to be great, but oh, that's pretty bad. All right, so going to look something like that, okay? I know the points don't line up exactly, okay? Now, identify the transformation. Notice that we have a 2 on the outside. So if we have a number on the outside, that's going to be a vertical transformation, okay? And then also, we remember that if it's positive on the outside, it's going to go up 2, okay? And we can go back to our rules, and we can notice that if we have f of x plus c, it's going to be shifted up 2 units. So again, it might be helpful to have like an index card or a piece of paper to write these down on, so that way you get used to those, right? So if I move everything up 2, and I'm just going to change the color of this graph, I move this point up 2, and then maybe this point up 2, and then this point up 2, and then this point up 2. All right, that's what a transformation does. It just moves all the points up 2 units, okay? And again, I know that's not perfect, but at least I moved the number of the coordinates up 2 units, okay? So this would be our function f of x equals x squared plus 2, and that's what a transformation does. It just moves the graph up, down, left, right, or reflects it. A secondary example, let me go back to the original color. And so this time we have the opposite of x squared plus 4 squared minus 1. Now, first of all, again, we have to name the parent function. Okay, so again, we have a square, so it's going to be quadratic. Okay, so that's pretty easy. Now, the next thing we need to do is we need to identify the transformations. So let's go for the easiest one first, which is the one on the outside. Okay, so this suggests that we're going to move down 1 unit. Okay, so and remember, if you have a number on the outside and it's negative, that just moves it down. Okay, so we're going to move down 1. This time we're inside the parentheses for this plus 4. And a lot of students might think that this is going to be right 4. All right, but unfortunately, it's not right. Remember, if it's on the inside, it's opposite. Okay, so we go back up to our rules. And remember, we say if it's f of x plus c, we're going to move left c units. Okay, so in fact, it's going to be 4 to the left right? And then the last thing that we noticed is that we have a negative on the outside of the parentheses, okay? So we have a negative on the outside. That means that we're going to be reflected. We have a negative on the outside in the x-axis, okay? So we're just going to move it upside down, all right? So if I were to describe the transformations, down 4, we're going to move, or down 1, excuse me, we're going to move left 4, and we're going to say reflect in the x-axis. All right, and so we know what the general quadratic looks like. And I'm going to do my best to draw this really nicely for you all. So there's a few points, by the way, on a quadratic that we should be cognizant of. So 0, 0, 1, 1, negative 1, 1, and then 4, 2, and then 2, I'm sorry, 2, 4, and then negative 2, 4. All right. If you keep those, okay, those are going to be like your basic ones. I mean, you can remember 9, 3 or 3, 9 if you want to, and negative 3, 9. I'm going to do my best to get through there. All right. So what we're going to do is we're going to take all of those points and we're just going to move them based on what we have here. And so usually the easiest one is just to take the origin. All right, so this is our parent function, as best as I can draw it, I know. And so we're going to move down 1. So let's just take this point. Okay, so we're going to move it down 1, and then we're going to move it left 4. Okay, and that's going to be right there. Now we're going to take all the other points. Okay, so we're going to move down 1. So let's take this point. We move down 1. We move left 4. So 1, 2, 3, 4. Okay. But then what we're going to do is we're going to reflect it. Okay. So that means it's going to be down here instead. All right. So, and then with the other one, it's going to be here. And so, and then finally, let's get just these other points. So we're going to move this, we're going to move it down 1, and then 1, 2, 3, 4. And then we're going to reflect it over the axis. All right. And we're going to end up right here. Right. And then similarly, this one over here. Right. And so the graph of the reflected function should look approximately like this. Okay. Notice it's a rigid transformation because we're not changing the shape of the graph. We're just changing its location and its reflection in the axis. Okay. So hopefully that's helpful for you to be able to see like some of these initial reflections. All right. So in subsequent videos, or sorry, also these transformations and reflections as well. So in subsequent videos, we're going to take a look at more of the parent functions, and we're also going to take a look at more transformations.